Welcome to episode 2 of Concept Crunch, and this is factorization part 2. So, in the last episode, we learned about grouping terms and taking out the highest common factor and factorizing that. So, now we are going to recap that or revise those, and then we are going to learn how to factorize using identities. So, first of all, the question for revision is x squared plus yz plus xy plus xz. Now we need to group this first. If we have 4 or more than 3 terms, we can group it easily. So we can see z is in this term and this term only. So we can only group those terms together. So yz plus xz. Now the rest of the terms we can group together, x squared plus xy. Okay, now we can take out the highest common factor, and in this case the highest common factor is z. So we are taking out that z. Now we are dividing yz by z, so this will cut out and we will get the remainder y plus xz by z. We'll cut out the z and we'll get the remainder x. Now factorizing this, we can take x as positive x out as the highest common factor, and x squared by x is x plus xy by x is y. So we can see that these two are common, so we can take that out, which will give us x plus y, and z plus x. So this is the answer, x plus y times x plus z, or z plus x. So now let's learn about factorization using identities. And the first identity is a plus b the whole square. What is a plus b the whole square? It is a plus b times a plus b, that is a plus b the whole square. So now how do we expand this? For the expansion purposes, we first multiply a and a. Which will give us a square. Then a and b, which will give us b square, ab. Now we will multiply b and a, which will give us ba, and b and b, which will give us b square. Now we can see ab and ba can be added, which give us 2ab. So a square plus 2ab plus b square, which gives us the first identity, a plus b the whole square equal to a square plus 2ab plus b square. This is the first identity. And how do we factorize using this identity? First of all, let's learn how to expand using this identity, a square plus 2ab plus b square. So the question we have here is expand 2x plus 3 the whole square. This is our question. How do we expand this term? So 2x plus 3 the whole square means let's take 2x as a and 3 as b. Okay, to connect it with this identity, we can substitute the a's and b's. So a square is 2x the whole square. We take whole square, not 2x square. This is wrong. 2x the whole square is correct. It is completely different things. 2 into 1 square is not equal to 2 into 1 the whole square. Okay, or 2 into 3 the whole square is not equal to 2 into 3 2 into 3 square. So so we need to check those minute details. So 2x square plus 2ab is 2 into 2x plus 3 plus b square, that is 3 square. So 2x square plus 2 into 2x plus 3 plus 3 square. So how do we expand that? Let's see. 2x square is 2 square into x square, so that is 4x square plus 2 into 2x plus into 3 is 6 into 2, 12x plus 3 square is 9. So this is the answer, 4x square plus 12x plus 9. Now for factorization purposes we have another question. 4y square plus 12yx plus 9x. How do we factorize this? So to check if something if we could factorize an expression using the first identity, we know a square plus 2ab plus b square has two perfect squares, b square and a square. So here we can see 4y square can be written as 2y the whole square, so that is a perfect square. 9x can be written as 3x the whole square, so that is also a perfect square. So that is correct and this is correct. Now 2ab, let's check if that comes. So here 3x into 2y, so it should be 2 into 3x into 2y. 2 into 2 4, 4 into 3 12, 12xy, it is correct. So we can write 4y square plus 12xy plus 9x as 2y the whole square plus we are finding the square root of 4 and square root of y and then whole squaring it. Okay, and same goes here and same goes here. Alright, then 2y the whole square plus 2 into 2y into 3x plus 3x the whole square, and we know that this is a plus b the whole square, or 2y is a, in this case a is 2y plus 3x is b, in this case 3x the whole square. So this is a factorized form, 2y plus 3x the whole square. So this is how you factorize using identity number 1, a plus b the whole square. Now another question, x of the same identity, x square plus 10x plus 25. Now how do we identify this is, we could use a plus b the whole square. 25 is a perfect square, as we could write it as 5 square. X square is a perfect square, as we could write as x square itself. So and 10x should be 2 into x into 5, which is correct. 2 into 5 is 10, 10 into x is 10x. So that is correct. So we could use a plus b the whole square here. So x square plus 10x plus 25. We could write this as x the whole square plus 2 into 5 into x plus 5 the whole square, and we could write identity 1 as the reason, and we could write this as x plus 5 the whole square. So x square plus 10x plus 25 could be written as x plus 5 the whole square. Next identity is a minus b the whole square. A minus b the whole square. So that is equal to a minus b into a minus b. First, a into a is a square. A into minus b is minus ab. Minus b into a is minus ba. Minus b into minus b is positive b square. Now this could be written as a square minus 2ab. Adding these two things, a square minus 2ab plus b square, which would give us a minus b the whole square equal to a square minus 2ab plus b square. Okay, a minus b the whole square equal to a square minus 2ab plus b square. Now how can we expand using this? So we have a question here. 4 minus 3 the whole square. 4 minus 3 the whole square is obviously 4 minus 3 is 1. The whole square is 1 itself. Now let's see if we can use our identity and find the same answer. So we should be getting 1 if we use the identity. If we are not getting 1, then the identity is wrong. So let's check. 4 minus b, the whole square is 4 square minus 2 into 4 into 3 plus 3 square. So that is 16 minus 8 into 3, 24 plus 9. Find the answer. So 16 minus 24 is minus 8 plus 9 equal to 1. So these two are equal, which means that the identity is correct. So this is how you expand using the identity. Now how do we factorize using this identity? So we have, first question is x square minus 8x plus 16. Now how to check if we could use a minus b the whole square? To check that, we should see first of all if two numbers or two terms of this expression are a perfect square. So 16 is a perfect square, as we could write it as 4 square, and x square is a perfect square, as we could write it as x square. Then we should check if the middle term or any other term is negative. In this case it is negative 8x, so that is also correct. That is also true. Then we could try and solve that using x square minus 8x plus 16. So now let's try solve it. X square minus 2 into, this could be written as 4 square, right? So we could write that there. 2 into, first a is x into b is 4. Now let's check if this is correct. Minus 2 into x is minus 2x, minus 2x into 4 is minus 8x. So this is also correct. So then we could write it as x minus 4 the whole square, remembering the identity. So this is how you factorize using identity a minus b the whole square. Now next question I have is 9m square plus 4n square minus 12mn. So actually in this case you can see the middle term is not negative, but the last term is negative. So this is a jumbled expression. The terms are jumbled a little bit. We have the commutative property, so that is allowed in addition. So what we could check is this a perfect square? Yes, we could write it as 2n the whole square. 2n the whole square is 4n square. So 2n the whole square. Don't forget the whole square. That is a main mistake that you guys do. 2n square is not equal to 2n the whole square. 2n square, let's take n as 3. 2 into 3 square is not equal to 2 into 3 the whole square. 2 into 3 square is 2 into 9, 18, not equal to 2 into 3, 6 square, which is 36. 18 is not equal to 36. So you should remember that. Don't forget the brackets. Okay, so 4n square could be written as 2n the whole square. This could be written as 2n the whole square. Now 9m square could be written as 3m the whole square. The whole square. Minus 12m could be written as minus 2 into 3m into 2n, right? Minus 2 into 3 minus 6, minus 6 into 2 minus 12, m into n, mn. So this we could use a minus b the whole square to factorize this. So let's factorize 9m square plus 4n square minus 12mn equals to 3m the whole square plus 2n the whole square minus 2 into 3m into 2n, which would give us a is 3m minus, the identity is a minus b the whole square, minus the b is 2n the whole square. So this is the factorized. So in this video I am only taking that much. Just remember a plus b the whole square equal to a square plus 2ab plus b square. A minus b the whole square equal to a square minus 2ab plus b square. We could jumble the terms. We could write a plus b the whole square as a square plus b square plus 2ab, and we could write a minus b the whole square as b square plus a square minus 2ab. So that's it for today. Thank you and have a nice day.